I was looking at the source material for today, and it struck me that most of baking, at least the way I do it, is basically masonry.
Masonry. How do you mean?
You're dealing with, like, bricks of butter, dense bags of flour, heavy creams. You're mixing mortar. It's heavy construction.
That's a fair analogy. I mean, the pound cake is literally named for a pound of butter, a pound of sugar.
Yep.
It is a dense, heavy object.
Exactly. But then you get to today's topic, angel food cake.
Yeah.
And it feels like we're trying to build a skyscraper out of, I don't know, soap bubbles.
Right.
It just defies the logic of everything else in the kitchen. There's no fat, no yolks, no butter. It's just protein and air.
And yet, if you do it right, it supports its own weight, it can hold frosting, it has genuine structural integrity. But you were right to call it an anomaly. It's the only cake that relies entirely on mechanical leavening, just air, instead of, baking powder or soda.
And that is what we're tackling today. We're doing a deep dive into Martha Stewart's masterclass on angel food cake. And I want to be super clear, everyone listening, this isn't just a recipe read-through.
No, because the ingredients list is deceptively simple. It's basically egg whites, sugar, and flour. If you just chuck those in a bowl, you'd get like a rubbery paste.
Right. Our mission today is to uncover the engineering behind this cake. Martha breaks down 3 variations: the classic white, a brown sugar version, and this structural marvel called the coconut cloud. We're going to figure out the physics of why they rise.
And why they don't collapse.
Yeah, and frankly, why they scare so many home bakers.
Oh, it is an intimidating cake. Because it's all about foam stability. Martha actually opens the source material by framing baking as an exact science. A stew, you can improvise, right? A little more wine, a little less salt. With angel food, you are performing chemistry. If you deviate, the whole reaction just fails.
So let's enter the lab. We have to start with the foundation.
Yeah.
The classic white angel food cake.
Yeah.
And the first number that just jumped out at me from the notes was 14.
The egg count.
14 large eggs. That is an obscene amount of eggs.
It is. You're looking for about 1 3/4 cups of liquid whites. But this is where the first critical lesson in chemistry comes in. Before she even turns the mixer on, Martha does something that just seems wrong.
Oh, I know what you're talking about.
She adds liquid water to the egg whites.
This stopped me in my tracks. I mean, usually water is the enemy of a meringue, right? You want stiff peaks, you want dryness. Why are we pouring a tablespoon of warm water into the bowl?
It's a total paradox, isn't it? But think about the protein you're working with. It's albumin. And when egg whites come out of the shell, those protein strands are all coiled up. Think of them like knotted little balls of yarn.
Okay.
If you start beating them immediately with high mechanical force, sometimes they can snap before they fully expand. And that can lead to a grainy texture.
So they snap instead of stretching.
Essentially. Martha explains that the warm water acts as a relaxant. It helps uncoil those albumin strands just enough so when you introduce the whisk, they're ready to trap air more efficiently. It kickstarts the whole process.
It's like stretching your hamstrings before you sprint.
Exactly. You're prepping the muscle. And notice she emphasizes warm water. Temperature is key here. Cold whites create a much tighter foam that doesn't expand as much in the oven. The warmth lowers the surface tension.
So you get more volume. Okay, so we've relaxed the proteins. We turn on the mixer. We're building the foam. Now we hit what she calls the stabilization phase. She adds salt, which, okay, that's for flavor, but then cream of tartar. I feel like cream of tartar is that ingredient everyone buys once, uses a teaspoon, and then it sits in the pantry for a decade.
And yet, for this cake, it is the single most important chemical you can add. You cannot skip it.
What is it actually doing? It's not just for taste.
No, it's all about pH control.
Yeah.
Egg whites are naturally a little bit alkaline. By adding cream of tartar, which is tartaric acid, you're lowering the pH of the whole mixture.
And what does that do to the proteins?
It changes their electrical charge. And this is the cool part. It prevents them from bonding too tightly with each other.
Wait, but don't we want them to bond? I mean, we're trying to build a cake.
You want them to bond around the air bubbles, but not to collapse onto themselves. The acid keeps that protein network flexible and strong. It stops the bubbles from, popping and joining together. That's what causes a cake to collapse or to weep liquid later.
So when she says it keeps the mixture dry?
That's what she means. It won't weep that sugary water at the bottom of the bowl. If you see a meringue with a puddle of sticky liquid, that's a protein network that failed. The acid prevents that.
Okay, so stable, acidic foam, check. Now we have to introduce the solids, the sugar and the flour. And this is where the process goes from gentle mixing to a full-on workout. She sifts the flour 4 times.
4 times. And she's using cake flour, which is already lighter than all-purpose.
Is this just Martha being a perfectionist? Or is there a real reason for sifting something 4 times?
Oh, it's purely functional. It's about density matching. Imagine you have this cloud of egg white foam. It's incredibly light. If you just dump a cup of flour onto it, even cake flour, that flour is basically a pile of rocks in comparison.
And it would just sink and crush all the bubbles.
Straight to the bottom. It crushes everything you just spent 10 minutes creating. By sifting, you're mechanically forcing air between the flour particles. You're trying to make the density of the dry stuff as close as possible to the density of the foam.
So they suspend in the foam instead of crushing it.
Precisely. It's not about removing lumps, it's about adding volume to the powder itself. And she uses superfine sugar caster sugar for a similar reason.
Right, the crystals are smaller.
Yeah. Granulated sugar crystals are heavy and have sharp edges. They can actually tear the protein balloons. Superfine sugar dissolves almost instantly, so it preserves that delicate network.
Okay, so you've got this batter. It's glossy. She made a point of saying glossy, not dry.
Yes, that's key. If it looks like styrofoam or like cotton balls, you've gone too far. You've tightened the proteins so much they can't expand in the oven. It needs to look like shaving cream. Smooth, shiny, flexible.
Shaving cream, not styrofoam. Got it. Now let's talk about the hardware. The pan. This felt like a very specific segment. She holds up this 10-inch tube pan made of spun aluminum.
Spun aluminum, yep. It conducts heat very quickly and evenly. But did you catch the detail about the texture of the metal?
She pointed out these tiny little marks on the side. They almost look like scratches.
Right. She calls them almost imperceptible marks. This is so crucial. If you use a modern, non-stick, heavy-gauge pan, you will probably fail at this cake.
Because of the no grease rule.
Exactly. This is the one cake where you want the batter to stick. In fact, you need it to stick. As those air bubbles expand with the heat, the batter has to literally climb the walls of the pan.
It's rock climbing.
It's rock climbing. It uses the friction of those little metal marks to pull itself up. If you butter the pan or use non-stick, you're just greasing the cliff face.
And it just slides back down.
Slides right down. And you end up with a dense, flat rubber puck instead of a tall, fluffy cake.
That is such a clear mental image.
Yeah.
And the fight against gravity continues even after it's baked.
The cooling process. This is where most people mess up.
Okay, so 350 degree, 35 to 40 minutes. It comes out golden. And then she flips it upside down.
Oh,
Immediately.
immediately. The cake is baked, but that protein structure is still soft and plastic because it's hot. If you let it cool right side up, the weight of the cake itself will compress those air bubbles. It'll just shrink.
So by flipping it, you're using gravity to stretch it out.
Yes. You're letting gravity pull the cake down away from the pan, keeping that structure elongated while the proteins cool down and set. It sort of freezes the fluffiness in place.
She showed a pan with little feet on it, which makes this easy. But I loved the throwback to the battle method.
Oh, it's iconic. Sticking the center tube of the pan over the neck of a wine bottle, it looks precarious, but it works. It's how my grandmother did it.
So that's the baseline, the classic white. And honestly, that alone feels like a masterclass in physics. But then Martha pivots. She introduces a second variable, the brown sugar angel food cake.
This is so interesting because chemically, brown sugar is completely different from white sugar.
It has molasses, so moisture.
Moisture, impurities, and acidity. And Martha is very specific here. You have to use light brown sugar.
Because dark brown sugar would be too heavy or too strong.
Both. Too heavy, too wet, and the flavor's way too aggressive. You just overwhelm everything. But even with the light brown sugar, you notice the color change in the batter. It's this sort of tannish color.
And the mixing technique changed too. With the white cake, she adds the sugar spoon by spoon really gently. Here, she mixed the brown sugar with the flour and added it almost all at once.
Right.
That seemed risky. Doesn't that knock the air out?
It does, a little bit. And that's why this cake is a bit denser, a bit moister. It's not quite as high-flying as the white version. It's more of a comfort version of angel food. You trade some volume for that caramel flavor.
She also switched up the form factor. She used these mini molds, 8 little individual cakes.
And this led to a great tip on process. I mean, have you ever tried to spoon sticky batter into a tiny muffin tin?
Oh, it's a nightmare. It gets everywhere. It drips. It burns. It's a mess.
A total mess. So Martha just bypasses all that. She grabs an 18-inch pastry bag with a half-inch tip, fills the bag, and just pipes the batter into the molds.
It looks so clean and efficient.
It is, but it also preserves the air. Every time you scoop batter with a spoon and plop it down, you're compressing it. Piping it is a continuous, gentle flow. It maintains the foam's integrity.
And I'm guessing the baking time drops way down, too.
Oh yeah, significantly, down to about 25 minutes, which also keeps the brown sugar from burning because molasses burns a lot faster than pure sugar.
She pairs this with espresso ice cream and hot fudge, which we will get to that fudge. But first, the third cake. The coconut cloud. This felt like the final exam.
It's the most structurally ambitious one, for sure.
It's not just a recipe change. It's a physical modification of the finished cake. She bakes a standard white angel food, cools it, and then she basically performs surgery on it.
The trenching technique.
She takes a big serrated knife and cuts the top inch of the cake off like a lid. Then she cuts a channel inside the cake. She hollows it out.
It is extremely risky. You're leaving a wall of cake about an inch thick on the inside and the outside. If you cut too deep, you go through the bottom too thin, and the whole thing collapses when you fill it.
Right. But why? Why not just put frosting on top like a normal person?
It's about the ratio of filling to cake. She wants every single bite to have a massive amount of filling, way more than you could get just by slathering the outside. It's engineering a flavor experience.
And that trench gets filled with what she calls 7-minute frosting. Now, I've heard of this, but it sounded complicated.
It's basically a Swiss meringue, a cooked meringue. You're whisking egg whites, sugar, water, and cream of tartar over a double boiler.
So you're cooking the eggs while you're whipping them.
You're doing two things. One, you're dissolving the sugar completely so there's zero grit. And two, you're heat treating the protein, which creates this incredibly stable structure that tastes like marshmallow fluff.
Why 7 minutes? Is it just a name?
No, it's a literal instruction. At that temperature, it takes about 7 minutes of constant beating to get the volume and stiffness you need. Stop early, it's soup. Go too long, it turns grainy. It's a very precise window.
But you flagged a big warning about this frosting, the Cinderella factor.
Yes, Martha is very clear. This is a day of frosting. It is hygroscopic. It just loves to absorb water from the air.
Hygroscopic. Good word.
So if you make this cake and leave it overnight, especially in a humid kitchen, that beautiful marshmallow fluff will just start to melt. It gets weepy and separates.
So the structural integrity has a time limit. It's ticking clock.
Exactly. You build it, you serve it, you eat it.
I kind of admire that.
Yeah.
So she fills the trench, puts the cake lid back on, and then plasters the whole outside with frosting.
And then the final layer, the coconut. 3 to 4 cups of fresh grated coconut.
It looked like a delicious shag carpet.
It actually serves a purpose, though. The coconut acts as a bit of a barrier, protecting the frosting from the air. But mostly it's texture. You have the soft cake, the marshmallow goo, and then the chew of the coconut.
And the surprise of slicing into it. You think it's just a white cake, and then you hit that hidden vein of frosting.
It's a great example of using the cake's structure to hide a payload. You couldn't do that with a heavy butter cake. It would just crumble.
Okay, we have to talk about the sauces. Let's go back to that hot fudge for the brown sugar cake.
Right. Hot fudge seems simple, but getting that perfect texture is hard. You want it pourable but thick.
She used an ingredient that I feel like has gotten a bad rap recently. Corn syrup.
Light corn syrup, and in this context, it's not just a sweetener, it's an interfering agent.
Interfering with what?
Crystallization. Table sugar sucrose wants to form crystals. If you just boil sugar and water and let it cool, the sugar molecules snap back together. That's what makes fudge grainy.
The worst.
Corn syrup is made of glucose chains. They're long and clumsy. They literally get in the way of the sucrose molecules trying to lock together. They physically block the crystal formation.
So they keep the mixture from setting up too hard.
They keep it malleable, as Martha puts it. That's why the fudge stays smooth and drippy, even when it hits cold ice cream.
And she finishes with butter and vanilla off the heat.
The butter is for sheen. It gives it that glossy, professional finish at the very end.
Then, for the classic white cake, she went in the complete opposite direction. Elderflower syrup.
This was peak lifestyle, Martha. She's harvesting fresh elderflowers from her garden.
She called them giant Queen Anne's lace, and she doesn't just boil it, which is what surprised me.
No, if you boil flowers, you destroy the aroma. The high heat just kills those delicate oils. She steeps them. She pours the warm syrup over the flowers and lets it sit at room temperature for 3 to 4 days.
3 to 4 days. That requires some serious planning.
Well, that's the difference between just cooking and actually crafting a flavor. It takes time for those volatile compounds, the scent, to migrate from the flour into the syrup without heat forcing them out.
And she serves that with brandywine berries and whipped cream. It's all about balance, isn't it?
Exactly. The light floral syrup for the light, airy cake. The dense, rich fudge for the denser, caramelly cake.
You know, the patience required for all of this.
Yeah.
And that's the theme here. The patience to sift 4 times. The patience to let it cool upside down for an hour.
And the discipline to follow the rules. With Angel Food Cake, the creativity is in the precision. It's classical music. You have to play the notes exactly as written.
You're right. The warm water isn't a suggestion. It's protein manipulation. The no grease rule isn't a preference. It's friction mechanics.
If you respect the science of it, what the albumin needs, what the air bubbles need, you get a result that feels like magic. But it's not magic. It's engineering.
It's edible engineering. And I really like that idea of the hidden trench in the coconut cloud. It feels like a metaphor for this whole thing.
How?
Well, you present this perfect, white, simple exterior to the world. But the real sweetness, the stuff that took the most effort, that 7-minute frosting, is buried deep inside where no one can see it.
That is surprisingly poetic for a conversation about egg whites.
I try. But seriously, it does make you look at baking differently. You're not just mixing, you're building something that has to fight gravity and heat. And when it wins,
You get to eat the victory. Martha calls the person who pulls this off an angel food hero.
I want to eat the victory. I think I'm ready to try and earn that title.
Just make sure you don't grease the pan.
Never grease the pan. Thanks for breaking all this down. Now go sift some flour.
4 times.
4 times. We'll see you in the next deep dive.